So we were supposed to discuss E0 values and direction of electron flow. Okay? So we can deduce the direction of electron flow in wires in external circuit by comparing the E0 values for two half cells that are connected together. Okay? For example, if we're connecting the zinc and silver cells together, take a look. Silver has a higher positive value, that is plus 0.80 volts. Zinc, on the other hand, is minus 0.76 volts. The relative value of these voltages tell us that zinc ions are more difficult to reduce than silver ions. So that's easier to understand that zinc will oxidize and silver will reduce. So zinc will lose electrons, silver will accept electrons, okay, in their half cells. The electrons move through the wires in the external circuit. They do not travel through the electrolyte solution. We already know that this entire structure consists of two parts actually for movement of charged particles. Let me come to the next page. So no, let me come to a diagram. Although this is not a related diagram, but this diagram is to give you an idea how the charged particle moves. Now, the electrons are the charged particles that move through the outer circuit, through the wiring. That is metallic conductivity, something we explained back in IGCSE. Okay? In metallic conductivity, the charged particles that move from one point to another point, because of which it is called a conductor, because of which the electric current can pass from one point to another, is the movement of electrons. In case of these solutions, the solutions are connected by a inverted U-shaped salt bridge. In case of salt bridge, the electrons do not go from one solution to another solution, but ions do. So in this case, this is electrolytic conductivity in which ions show the movement. So in the inner part or in the bottom part, the ions move, hence the charged particles move, because of which the circuit is completed. And in the outer portion, in the wiring portion, the electrons move from one point to another. See? So that's why the E0 values in direction of electron flow depends upon these values. Let's understand it completely. So the electron flow is from the zinc half cell to the silver half cell. Now that is very easy to understand. Why is it from zinc half cell to silver half cell? Here, zinc is getting oxidized, losing electrons. So electrons will be lost from that half cell and will go all the way to the other half cell, that is the silver half cell, through the wiring, through the external circuit. I mean, hence the flow is from zinc half cell to silver half cell. Hence the flow is from negative pole to the positive pole. It may help you to remember that more positive pole attracts the negative electrons. So of course the electron go from the negative pole to the positive pole. See? In the electrochemical cell in figure 20.17, electrons move in the external half circuit from the copper cell to the iron cell, and the values are given as iron with a higher positive value and copper with a lower positive value. The negative pole of this cell is provided by copper, of course. Okay? This is because copper is better at losing electrons than iron half cell. Okay?
Sir, copper is better at gaining electron नहीं होगा?
देखिए, इस केस में हमारे पास कॉपर की वैल्यू लेस पॉजिटिव है, आयरन की वैल्यू मोर पॉजिटिव है. हमने पहले भी केस डिस्कस किया हुआ है, ठीक है, जिसमें वैल्यू हमारे पास लेस पॉजिटिव हो जाती है, इट्स बेटर एट ऑक्सीडाइजिंग, ठीक है, और जिसमें हायर पॉजिटिव हो जाती है, इट्स बेटर एट रिडक्शन, ठीक है. So in this case, iron is better at reduction and copper is better at, comparatively, copper is better at oxidation. So copper becomes the negative pole and iron becomes the positive pole. And as we have told before, it moves from negative to the positive pole, hence from the copper half cell to the iron half cell. Are we all clear? Yeah, अभी भी confusion है.
आयरन की ज्यादा रिएक्टिविटी की वजह से ये होता है,
नहीं नहीं नहीं, अब यहाँ पे रिएक्टिविटी मैटर ही नहीं कर रही बेटा। और से देखें, एक जो है वो हमारे पास मेटल और मेटल आयन का हाफ सेल है, लेकिन दूसरा हाफ सेल मेटल और मेटल आयन का नहीं है, वो आयन आयन हाफ सेल है। नोटिस करें गौर से। और जब आयन आयन हाफ सेल होता है हमारे पास सिस्टम में अटैच, ये नॉन मेटल के आयन का हाफ सेल होता है, देन रिएक्टिविटी डजंट मैटर। फिर रिएक्टिविटी सीरीज जो हमने आईजीसीएसई में पढ़ रखी होती है, उस कॉन्सेप्ट को आप यूज नहीं कर सकते। ये मैं 2-3 दिन पहले के जो हमारे टॉपिक्स गुजरे हैं उसमें ये बात एक्सप्लेन कर चुका हूँ कि जहां तो बेटा आपके पास मेटल मेटल आयन का सेल आता है, वहां पर तो आपके लिए ठीक है, लेकिन जहां आपके पास नॉन मेटल का उसके आयन के साथ हाफ सेल आ जाए या आयन आयन का हाफ सेल आ जाए, फिर आप रिएक्टिविटी सीरीज से नहीं देख सकते। फिर आपको सिर्फ और सिर्फ ई स्टैंडर्ड वैल्यूज के हिसाब से चलना पड़ेगा। और मैं इस वक्त एक्सप्लेनेशन भी सिर्फ और सिर्फ ई स्टैंडर्ड वैल्यूज के तौर पे कर रहा हूँ। क्यों? क्योंकि मैं रिएक्टिविटी के हिसाब से एक्सप्लेनेशन ही नहीं कर सकता। बात तो इस वक्त Cu यानी कॉपर आयरन +2 और आयरन +3 के आयंस की हो रही है, और रिएक्टिविटी सीरीज में आपको कॉपर के अलावा आयरन +2 और +3 के आयंस की रिएक्टिविटी नहीं लिखी होती। So we are unable to take it from the reactivity series that we have previously studied in IGCSE. That is of no use or help here. That might give you an idea, but that cannot give you a proper, accurate decision. Why? Because the ions were not included in that reactivity series. मेरी बात क्लियर हो रही है? ये बात मैं पहले भी कर चुका हूँ, इसलिए अब इतनी अच्छी तरह से एक्सप्लेन कर रहा हूँ कि आप ये वाली मिस्टेक कतई ना करें। वो कि मैंने आपको मेटल्स के लिए ये बात सिखाई है कि आप रिएक्टिविटी सीरीज को देख सकते हैं, बट इट इज ओनली लिमिटेड टू मेटल्स। As soon as you talk about a non-metal, as soon as you start comparing ions, even the ions are belong to the metal ions, they cannot be compared on the basis of reactivity. Then the only option we have is the E naught or E standard values. Clear हो गया? हुज़ैमा, अली, आप दोनों क्वेश्चंस कर रहे थे, किसी और का भी क्वेश्चन है पूछ लें।
नहीं सर।
Okay, good. So this decision that copper will become the negative cell and negative pole, sorry, and iron will become the positive, and the electrons will flow from copper to iron is solely made on the E standard values. See, moving on. There are a couple of questions in here. Question number 20. It's very easy to compare and to discuss whether what would be the electron flow. Okay? And they've already discussed that appendix 2 can be used over here. So of course you can go ahead and use appendix 2. What is appendix 2? Appendix 2 is actually the E standard values. So with the help of E standard values, any of these equations can be considered and discussed. All right. So moving on.
सर ये values तो हमें उसमें भी दी होती है ना, उसमें
data booklet.
Data booklet.
Yeah, the appendices are for data booklets. ठीक, वो बुक के एंड पे भी इसलिए दी होती हैं क्योंकि वही वाली अपेंडिसेस आपके पास डाटा बुकलेट में भी होती हैं, तो बुक के एंड पे आप उनसे यूज टू हो जाते हैं और फिर डाटा बुकलेट में भी वही वाली चीज होती है। ठीक, ओके। Now remember, we are using E naught for many different purposes over here. You might not be noticing that, but every topic that we are doing is actually the usage of E naught values for a specific purpose. Let's scroll a little bit back and take a look at it. Using E naught values, the first point was to predict cell voltage. We did that as a topic. The second one was to predict the direction of electron flow. This was the second one. And here comes the third one. We're going to predict if the reaction will occur, if a reaction is feasible or not feasible. Okay, so actually we are using E standard and E naught values for many different purposes. And that's what happens in A2 exams, that if there is a question about E naught values, they may ask about any of these usages, or they may make a combination. And combination is usually their favorite. Asking a couple of things from E naught values is something that they do like. See? So the third thing that we can do from an E naught value is to predict whether a reaction is feasible, whether a reaction will occur or will not occur. Now the E standard values give us a measure of how difficult or easy it is to oxidize or reduce the species. And we can compare these oxidizing and reducing powers of species, and we can discuss them for half reactions, whether they will happen or not happen. Take a Figure 20.18 compares the oxidizing and reducing powers of the selected elements and ions. The figure at the bottom of this page, we'll get to that figure. But before we go over there, the E naught values are listed in the order of increasing negative values. For each half equation, the more oxidized form is on the left and more in reduced form is on the right. Okay? So increasing negative from a higher positive value all the way from to a higher negative value. Okay? And as he told, we can discuss their oxidizing or reducing capabilities. Now take a look. Strongest oxidizing agent are on top and weakest oxidizing agent are at bottom. Vice versa, strongest reducing agent are at the bottom and weakest reducing agent are on the top. So saying that increasing oxidizing power of ions and molecules on the left, increasing, that is an increasing tendency of gaining electrons. On another way of writing it, increasing reducing power of the element on the right, which is increasing tendency to lose electrons. Okay? As you can see, these are all ions and these are all elements except one on the top. Okay? So because that's a non-metal, the equation is reversed in case of a non-metal. So for all these metals, we have this statement, and for all these ions, we have this statement. So these statements help us understand how they are going to behave if we try to make a list. And making a list is actually very helpful. That's what Appendix 2 is about. We start comparing element by element, no matter it's a metal or a non-metal. We start comparing the E naught values to another one, then we add another one to the list. And as you can see, this list is already made up of 6 different elements, okay? Out of which 2 are non-metals and the rest 4 are metals. Okay? Let's go through these points in order to understand it. The more positive value of E naught, the greater the tendency of the half equation to produce in the forward direction, which means if it's positive, it will tend to reduce itself. So of course, it is going to move forward as much as it can for a higher positive value. And of course, vice versa. Okay? Of course, vice versa is true. Coming back to the second point, less positive value of E standard, the greater the tendency for the half equation to produce in the reverse direction. I just explained that vice versa is also true. Okay? Coming on to the third point, the more positive the value of E standard, the easier it is to reduce the species on the left of the half equation. Okay? Which means the left of the half equation is easier to reduce for a higher positive value, and vice versa for a higher negative value, for which we probably have point number 4, which says the less positive value of E standard, the easier it is to oxidize the species on the right of the half equation. Hence, the chances are that it would go in the reverse direction, which was explained in point 2. So point 2 and 4 are similar, and point 1 and 3 are quite similar. Are we clear with these points?
Yes, sir.
Okay, if we are clear with these
Yes,
points,
sir.
let's do a small practice. This same kind of practice I tend to do every time I go through a topic. Take care. So, Husama, you're here. Let's start with you. Husama, which one's easy to reduce? Silver ions or silver metal?
Silver
आप
ions.
बेशक बुक अपने अपने सामने ओपन कर लें और पॉइंट्स अपने सामने खोलें. I don't mind if you're taking a look at the book and then answering me the question. That's fine by me. ठीक है. But you're supposed to be
Silver
correct.
ions.
Very good, Khuzama. ठीक है. Talking about chlorine in the form of gas and chloride ions, and this time the question is for Alwan. Which ones are easy to oxidize? A chlorine molecule or chloride ions? Which ones are easier to oxidize? Alwan.
सलमान ज्वाइन नहीं की क्लास।
ओह, अलवान ने शुरू में तो ज्वाइन की हुई थी, मेरा ख्याल है रिमूव हो गए। अच्छा हाँ, ठीक ठीक ठीक। अच्छा आयशा आ गई। चले अली, यू मे आंसर द क्वेश्चन।
सर क्लोरीन गैस
आर यू श्योर?
easier to reduce, yes.
No, I asked easier to oxidize. Well, you are correct
Oxidize.
with your answer, but I asked a different question. Okay,
अच्छा
no problem, no problem. But you're still
फिर
correct. That
opposite
means
होगा।
if, of course, the vice versa is also true. Good, good. So, Roma, coming to you, talking about magnesium. Are magnesium ions easier to reduce? Yes or no?
एक मिनट
Do I repeat my question?
सर कैन जी सर कैन यू प्लीज रिपीट द क्वेश्चन?
And my question was, are magnesium ions easier to reduce? Yes or no?
यस
See,
सॉरी सॉरी नो नो सॉरी सॉरी सर मुझे लगा वो
magnesium tends to
सॉरी सर
oxidize.
यस
So
सॉरी
the
मिस्टेक
magnesium ions are a more
तो वाइस
stable
वर्सा
form. So they are
यस
difficult to reduce. So the answer to this question is no. ठीक है?
जी
Okay, आयशा बेटा आप बताएं आपने कितने टाइम बाद क्लास ज्वाइन किया? Means if I ask you a question from this list, will you be able to answer? Can you try?
सर पूछ ले आई विल ट्राई
Okay, okay, that's good. That's good. Aisha, talking about hydrogen gas molecule, and in order to balance it, they have taken a half a molecule. Is hydrogen molecule easier to oxidize?
सर आई थिंक सो इट इज बिकॉज़ शायद एक आई गेस यस
अच्छा, आयशा आपका क्वेश्चन कंफ्यूजिंग इसलिए है कि हम एक ऐसी चीज की बात करें लिस्ट में जो ना तो हायर पॉजिटिव वैल्यू रखती है और ना ही हायर नेगेटिव वैल्यू रखती है। ठीक है, number one. Number two, for all the metals, they tend to lose electrons. For the non-metals, they tend to gain electron. Hydrogen, as we discussed back in IGCSE, which is a unique element which can gain electron as well as lose electrons, right? So it's going to be different. So in this case, yeah, it has a mediocre value. It's easier to reduce as well as easier to oxidize. In order to reduce hydrogen ions, this is going to go for the same capacity as it is for to oxidize the hydrogen molecule.
So if you say कि मतलब it is easier to reduce तो इसका आंसर yes हो सकता है right?
हाँ, इसका आंसर yes में भी हो सकता है, इसका आंसर no में भी हो सकता है। ठीक है ना? It's actually a mediocre value. It's actually showing a trend which is capable of going in both directions. ठीक है? So yes, your answer is correct, but this question, if is comparative with some other element, ठीक है, can be answered in a much better way than if it's asked individually. ठीक है? So what I'm going to do is that I'm going to change my question this time, just to check whether you're on the same page with me. Now, what we are going to do is that we're going to compare the molecule of hydrogen with the atom of copper, and I'm going to pass a statement, and you're going to tell me whether I'm true or not. Okay? The molecule of hydrogen is easier to oxidize than than an atom of copper, than an atom of copper. Easier to oxidize. Is that true or not?
नहीं sir.
Why?
Because sir वो ज़्यादा positive है copper hydrogen से.
Okay. So copper would be easier to reduce, and hydrogen would be difficult to reduce, which means hydrogen with a molecule would be easier to oxidize and copper would be difficult to oxidize. Am I not correct? या मैं तेज बोल गया हूँ?
नहीं आप सही है मैं
हाँ बिल्कुल बिल्कुल अब ध्यान से सुने और समझे, मैं इसे दोबारा स्लोली रिपीट करता हूँ, मैं हो सकता है तेज बोल गया हूँ, आपने फॉलो ना किया। कॉपर और हाइड्रोजन में से जो हायर पॉजिटिव वैल्यू है वो कॉपर की है। हायर पॉजिटिव वैल्यू ये शो करती है कि कॉपर आयंस इजियर टू रिड्यूस हैं, डिफिकल्ट टू ऑक्सीडाइज हैं, ठीक है। और अगर
जी सर।
हाइड्रोजन को इससे कंपेयर किया जाए तो हाइड्रोजन समवट डिफिकल्ट टू रिड्यूस और इजियर टू ऑक्सीडाइज हो जाएगा। So if I say that hydrogen molecule is easier to oxidize than copper, then I'm true.
यस सर।
ठीक है। I hope everyone in the class followed. Right? इन बातों को
यस सर।
जितना मैं इस वक्त घुमा घुमा
इन
के कर रहा
कंपेयर
हूँ,
टू सर, इन कंपेयर टू हाइड्रोजन कॉपर ज्यादा मतलब ऑक्सीडाइज मतलब ऑक्सीडाइज हो जाएगा या हाइड्रोजन ज्यादा जल्दी होगा?
हाइड्रोजन
कॉपर
ज्यादा
होगा।
जल्दी होगा,
ज्यादा
हाइड्रोजन
जल्दी
जल्दी
होगा।
होगा। Copper
तो
actually
कॉपर
has a higher positive value, so it
इसीलिए
likes
जल्दी
to get reduced. ठीक है.
यस।
On the other hand, oxidation would not be as good as the reduction was. ठीक है. So if we are comparing it with hydrogen and it has a lower positive value, of course its oxidation would be easier and its reduction is going to be difficult.
यस।
See, that's what we have been saying. For a more positive value, remember the oxidation is easier. Okay, and for the lesser positive value, the reduction is easier. My mistake, my mistake. I might have confused you. Let me pass this statement again, the correct one this time. For a higher positive value, it's easier to reduce. Okay, so for a lower positive value, it is going to be the opposite. It would be easier to oxidize. See,
यस।
hence the one at the top of the list is the most easily reducible one, and one at the bottom of the list is the least reducible one or the easily oxidizable one. ठीक है. इसी वजह से मैग्नीशियम being a metal एक oxidizing character रखता है और electrons lose करना पसंद करता है. Something that we told you back in IGCSE. We're just using E0 values to prove the same reactivity we explained you back in IGCSE. Metals like to lose electrons. Magnesium on this list will be the most favorable one for this act. It would be easiest for magnesium to lose electrons. On the other hand, non-metal like to gain electron. So from this list, chlorine would like to gain electron, and chlorine would be the one that can easily be reduced. ठीक है. सो वही चीज जो हमने आईजीसीएसई में रिएक्टिविटी या मेटल नॉन मेटल की बेसिक प्रॉपर्टीज में पढ़ी थी, उसी चीज को हम दोबारा प्रूव कर रहे हैं ई नॉट वैल्यू से. And this time we are proving it mathematically. We have a proper voltage to discuss that having a higher positive or a lower positive value will make the species behave how. ठीक है.
तो सर व्हाइल कोटिंग द मतलब अगर हमसे ये क्वेश्चन पूछा जाता है तो हमें वैल्यू से कोट करना होगा ना एज अ रेफरेंस?
वैल्यूज लिखी होंगी, आपने अपने डिडक्शंस देनी होंगी. ठीक है. अगर वैल्यू नहीं लिखी हुई तो प्रोबेबली वो ये चाहते होंगे कि पहले आप अपेंडिक्स से वैल्यू देखें फिर अपनी डिडक्शंस लिखें. In that case, if you're looking it up from the appendix, I mean the data booklet in case of your exams, ठीक है, then you're supposed to quote the value as well. फिर बताएं वैल्यू. अगर तो ऊपर क्वेश्चन में दी हुई है तो भी आप वैल्यू आंसर में कोट कर सकते हैं, लेकिन अगर समटाइम्स क्वेश्चन नहीं होती और वो ये कह रहे होते हैं कि आप कंसर्न डाटा बुकलेट देखेंगे, फिर तो आपने वैल्यू आंसर में हर सूरत बतानी है क्योंकि वो ऊपर क्वेश्चन में मौजूद नहीं थी. दैट वुड क्लैरिफाई योर आंसर मच मोर. ठीक है. Okay, good. So moving on, there are a few examples over here in the book. Let's go through those examples. In case of copper, the value is plus 0.34 volts. In case of zinc, it is minus 0.76. When these two half cells are connected together, a reaction takes place in each of the half cells. The E0 values can easily be used to predict whether the reaction happening in each half cell is a reduction reaction, which in this case is a forward reaction, or an oxidation reaction, which in this case is a backward reaction. If the reaction happening in each cells are combined, we can produce an ionic equation for the whole reaction that is taking place in the electrochemical cell. Okay? For example, copper has a greater tendency to get reduced, I mean to gain electrons, and zinc has a better tendency to lose electrons, I mean oxidize. Okay? So the chemical reaction that proceeds in this half cell in the forward direction is this one. Copper plus electrons give us copper solid, right? So that's why we use these reactions and we write them like this. See, are we clear with figure 20.18? If you have any
Yes,
questions,
sir.
okay, good. So zinc has a greater tendency to lose electrons than copper. So the chemical reaction that proceeds in the half cell of zinc would be written like this. If we combine these two equations, then reaction becomes this. We simply cut out the electrons from both sides because they are equal. So zinc plus copper ions give us zinc ions plus copper, something we've studied back in IGCSE as an example of a proper redox reaction, in which one element loses electron, in this case zinc, and the other one gains those same electrons, in this case the copper ions. Okay? So this is the reaction taking place in the electrochemical cell, but it is also the reaction that takes place if a piece of zinc metal is placed directly into a 1 mole per decimeter cube solution of copper ions. The reaction is said to be feasible if it is likely to occur. In this case, the reaction is much likely to occur between zinc metal and copper ions. Take a look. This is zinc strip dipped into a copper sulfate blue colored solution. After some time, you would see that red-brown copper atoms are deposited on zinc, changing the color of zinc strip, and the solution had faded. Why? Because most of the copper ions from the solution will tend to go and get deposited on the zinc strip. Okay? On the other hand, take a zinc sulfate solution, which is actually colorless, take a red-brown copper strip, put it in the solution, there is no change, which means the reverse of this reaction cannot happen. That's why if you take a look, these arrows are irreversible. However, on the previous page, when we were discussing these equations, the half cell equations, they were used with a reversible arrow. Clear? So if we are going with an entire electrochemical cell, maybe only one type of reaction, that is the forward reaction, is possible and the reverse is not possible. In case of feasibility, only provided if it's feasible. Okay? So we can predict whether a reaction is likely to occur by referring to a list of half reactions with their E standard values, listed in descending order from most positive to most negative, which is figure 20.18, or which is appendix 2, okay, for us. So when we select half equations, the direction of reaction is given by a clockwise spectrum: reactant, product, reactant, product, starting from top left as shown in figure 2020 for the cell made for two half cells, copper ions, copper, zinc ions, zinc cell. Okay? Take a look. In case of E standard values, zinc has a higher positive value plus 0.34. Sorry, copper has a higher positive value plus 0.34. Zinc has a negative value minus 0.76. So the equations can be written as that it is a better oxidant or a reactant to give us the product, and this is a better reductant or a reactant to give us the product. So zinc likes to oxidize, and copper ions like to get reduced. See? Are we clear, students, with figure 2020?
Yes.
Okay. Good. Then there is a worked example. Will chlorine oxidize Fe2 ions to Fe3 ions? Okay. Let's take a look at chlorine's equation. Plus 1.36, iron 3 into iron 2, plus 0.77. Okay. Identify the stronger oxidizing agent and the stronger reducing agent. Cl2 is the better oxidizing agent because the more positive value of E0 indicates that Cl2 molecules are more likely to accept electrons than the Fe3 positive ions. Right? higher positive value, this will tend to get reduced. So Cl2 will get reduced, hence a better oxidizing agent. Are we clear about first point?
Yes, sir.
Okay, moving on to the second point. The stronger oxidizing agent, we mean chlorine, ठीक है, reacts with the stronger reducing agent, meaning that the reaction is feasible. ठीक है? So Fe2 was a better reducing agent. This one was a stronger oxidizing agent. On the exact opposite end, we have the stronger reducing agent. ठीक है? So this means they can react with one another. So chlorine can react with Fe2, ठीक है? Meaning the reaction would be feasible. The top reaction goes in the forward direction, the bottom reaction goes in the reverse direction. Combining the two half cells, it becomes like this. Cl2 plus Fe positive 2 gives us Cl negative plus Fe positive 3. Okay? If you take a look, this time in order to combine the half equations, they have reversed the iron equation. It wasn't written like this in the start of the question. Take a look. Fe plus 3 plus electrons give us Fe plus 2. In this case, Fe plus 2 is converted into Fe plus 3 plus electrons. Do you notice this change and do you understand the entire thing?
Nice.
क्या समझती हैं? चेंज तो नोटिस कर ली ना खुजैमा? मेरा ख्याल है चेंज नोटिस कर लिए लेकिन चेंज समझ नहीं आई, ऐसा ही है?
जी सर।
अच्छा खुजैमा देखें, मैं दोबारा अपनी एक्सप्लेनेशन कर रहा हूं और इस मर्तबा मैं फिर एक्सप्लेनेशन को कंप्लीटली ई नॉट वैल्यूज पर रख रहा हूं. सो मेरा फोकस भी इसी पर होगा, आपने भी फोकस इसी पर रखना है. Let me start explaining by asking you some questions. Huzaima, which equation has a higher positive value?
Cl वाली.
Cl value, right? So chlorine will tend to reduce more. Why? Because it has a higher positive value. Are we clear so far?
Yes.
And the lower positive value, which is for iron, will tend to get oxidized, which means it will try to move in the reverse direction. Is that correct?
जी सर.
बिल्कुल. उसको लोअर पॉजिटिव वैल्यू होती है, वो रिड्यूस होने की कोशिश नहीं करता, वो फिर ऑक्सीडाइज होता है. ठीक है ना? तो इस केस में क्या होगा? इक्वेशन ऑपोजिट हो जाएगी. इस वजह से हमने इक्वेशन रिवर्ट की. इतना हिस्सा तो इक्वेशन रिवर्ट करने के हिसाब से आपको समझ आ गया होगा. बाकी जो इसमें चीजें लिखी हुई हैं उसे अंडरस्टैंड कर लेते हैं. जिसकी हायर पॉजिटिव वैल्यू होती है उसकी लेफ्ट साइड पर जो होता है हमारे पास ऐसी चीज होती है जो रिड्यूस होना पसंद करती है, राइट? और जो चीज रिड्यूस हो रही होती है उसको कौन सा एजेंट बुलाते हैं?
ऑक्सीडाइजिंग एजेंट.
सो Cl2 एक अच्छा ऑक्सीडाइजिंग एजेंट होगा. यही नीचे पहले पॉइंट के पहले पैराग्राफ में लिखा हुआ है, Cl2 इज द बेटर ऑक्सीडाइजिंग एजेंट. ये बात क्लियर हो गई? उससे अगले पैराग्राफ को अंडरस्टैंड करते हैं. हायर पॉजिटिव वैल्यू वाला अगर अच्छी तरह से रिड्यूस होता है तो लोअर पॉजिटिव वैल्यू पे जो राइट हैंड साइड पे है वो अच्छी तरह से ऑक्सीडाइज होगा. ऐसा ही है, राइट? ऐसा ही होता है ना? तो Fe पॉजिटिव 2 अगर अच्छी तरह से ऑक्सीडाइज होगा तो ये कौन सा एजेंट हो जाएगा?
रिड्यूसिंग एजेंट.
दैट्स व्हाट वी हैव सेकंड पैराग्राफ फॉर. इतना क्लियर हो गया? अब हमने ये समझना है कि रिडॉक्स रिएक्शन जो होता है वो ऑक्सीडाइजिंग और रिड्यूसिंग एजेंट के दरमियान में होता है. ये बात तो हमने आईजीसीएसई में भी की हुई है. पता है ना कि रिडॉक्स रिएक्शन, साइमल्टेनियस रिडक्शन रिएक्शन, ऑक्सीडेशन रिडक्शन रिएक्शन तभी होता है when on one side there is the reducing agent and on the other there is the oxidizing agent, right? reducing agent हमने किसे कहा? इस क्लोरीन को, half Cl2 को. reducing agent नहीं, रिड्यूस होने वाला स्पीसी यानी कि ऑक्सीडाइजिंग एजेंट हमने हाफ Cl2 को कहा, और रिड्यूसिंग एजेंट कह रहे हैं हम किसको? Fe positive 2 को. तो ये दोनों आपस में रिएक्ट करने हैं. तो हमने इक्वेशन रिवर्स करके लिखी और दोनों रिएक्टेंट्स को कंबाइन करके रिएक्टेंट साइड पे लिख दिया, दोनों प्रोडक्ट्स को कंबाइन करके प्रोडक्ट साइड पे लिख दिया. इसी तरह से हमारे पास थर्ड पॉइंट भी बना और कंप्लीट ओवरऑल इक्वेशन भी फॉर्म हो गई. अब पूरा ब्लू पोर्शन समझ आ गया खुजैमा? गुड. द कॉल इज अबाउट टू एंड, सो लेट्स फिनिश इट ओवर हियर. ठीक है? इतना आज के लिए काफी है, एग्जाम्पल्स बाद में कर लें, क्लास यहीं